Okay, so we're taking a look at Chapter 5 assignment, problem 15. We've got Bob who's sending tweets on his lunch hour, and we're told that the tweets per hour follows a Poisson distribution and that Bob receives, on average, 7 tweets during his lunch hour. So in the interest of time, I've entered in the answers for each of these, but I want to go through, demonstrate how to solve the problem to get each answer, and discuss the logic behind it. So of course you could do this problem by hand with your calculator, and if so, that's fine. You simply have to follow the equation in the text. But I've programmed this equation in, and you simply have to, if you can't find this Poisson tab, right-click in between the two arrowheads in the lower left-hand corner of the spreadsheet, look for Poisson, click OK, and it'll bring you to this page. Now, they told you that the frequency of the tweets, the average, which is denoted as lambda, the average number of tweets that he receives is 7. So we enter the 7, and that's the only input for the Poisson distribution formula. So then I have x, the probability of x. I have the cumulative probability of x, which is everything less than or equal to x in terms of probability. And then the probability of that x is greater than some value. And these values are the x values in this first column. So the probability that Bob receives 0 tweets in an hour is 0.0009, because we want the answers to 4 decimal places. Next, we want to know what is the probability that the number of tweets is 4 or more. Or actually, they said at least 4, but that's the same thing as saying 4 or more. So we have x equal to 4, but what you have to keep in mind for this tool is that the second column is the cumulative probability for all values less than or equal to that x value. The last column is the probability of more than that value, more than x. Now you might be tempted to use this value here, 0.8270, but that would not be correct because we want to know less than or equal to 4. And saying less than or equal to 4 is the same as saying the probability that x is greater than 3, which would be the 0.9182, which is the correct answer, 0.9182. Next, they ask, what is the expected value for the number of tweets? Well, the expected value is the same thing as the mean, so the expected value would be 7. Although they said the expected value in 30 minutes. So the expected value in 30 minutes would simply be half of the expected value that you would get for 60 minutes, which is why C is 3.5, half of 7. Lastly, they ask, what is the probability that Bob will get 0 tweets in 30 minutes? Now, at first glance, you might expect that it would be the same number, but no, because in 30 minutes, the average is half of 7, or 3.5, which we just found out in the C part of the problem. So you need to change the mean, or lambda, to 3.5. When you do that, you see that the probability that he'll get 0 tweets in 30 minutes changes to 0.0302. So that's how you would use the statistical toolkit to solve these problems. But again, as I said, you could use the formula for these problems, and the formula for the Poisson distribution is actually a built-in function using the mean, the x value, Well, actually, the first entry is the x value, the second is the mean, and then you can determine whether or not you want it to be cumulative. So in the first column, we use false for the cumulative parameter, but in the second usage of the Poisson distribution, we use true because we do want to calculate the cumulative probability for everything less than or equal to that x value. In the last column, I simply took that cumulative probability and subtracted it from 1 to give me the probability of everything greater than that x value. But this spreadsheet is actually in your textbook if you wanted to build it yourself, but you already have it.